Section 9.8, Special Segments in a Circle with Algebraic Expressions. Our objective is students will successfully use properties of chords, secants, and tangents to solve segments measure problems. So as you can see, this problem is not much different than yesterday's problems. However, there is a little bit of algebra involved in these now. So first thing that I notice is that there's no letters on the picture. So go ahead and add letters. And then next, we need to decide, is this X, big V, little v, or weird V? So this is the weird V. So we start with from the intersection point of the two lines, so point B, and we go out to the edge of the circle. And we're going to start with the side that has two pieces. So that side is going to be called segment BD times the little v part of that side, so BC, equals that weird side squared. Okay. Now for side BD, we don't know the length of it, so we have to use an algebraic expression to write what BD is worth. So DC is X and CB is 27, so that whole side is X plus 27. So BD is X plus 27. Remember, we have to add to get that whole piece. Okay. Now for BC, it is 27. BA is 36. So we get X plus 27, that quantity, times 27 equals 36 squared. Okay. Distributing the 27, we get 27x plus 729 equals, and now we need to square the 36, so 1296. Now we're going to use some algebra. Subtract 729 from both sides. We get 27x equals 567. Divide by 27, and x equals 21. Another example. Again, first thing I see is there's no letters on the picture, so we need to put some letters. I used A, B, C, D, and E. And now we have to decide, is this X, big V, little v, or weird V? So I see it as an X. So remember, we're going to take the pieces on one leg, and we're going to go from the intersection out to the edge of the circle. So our first piece we're going to do is EA. Our second piece on that leg is EC. And order really doesn't matter in how you write those two, so you could write EC and EA if you wanted. Equals the two pieces on the other leg. So again, start from your intersection point, and we're going to go with ED times EB. So intersection towards edge of side of circle. Okay. EA is worth 16, EC is 3x plus 1, ED is 14, and EB is 4x. Okay. On that left side we need to do some simplifying, and on the right side we need to do some simplifying. So 16 times 3x plus 1 is 48x plus 16, 14 times 4x is 56. We're going to move our x's to the same side, so subtract 48x from both sides, and we get 16 equals 8x. We're going to divide by divide by 8 to get x by itself, and x is going to equal 2. Okay, another problem. Again, I see that this does not have letters on it, so we are going to go ahead and use A, B, C, and D and E to label the points. Okay. Next we're going to decide, is this X, big V, little v, or weird V? Hopefully you all see this as big V, little v. We're going to start with that bottom side, and our big V is, again, we want to go from the vertex of the V, so that's C, all the way to the far side of the circle. So CE is our first segment, and then our little v on that side is CD. Equals, and now we're going to go over to the other side, our big V side on that one is CA, and our little v on that side is CB. Now for CE, remember it's the whole piece, not just one. So we have to add to get that length. So x plus 3 plus 10. That's going to get us x plus 13. So CE is x plus 13. CD is the 10. Okay, again, over on the other side, CA, we're going to have to add to get the whole segment. So 2x plus 1 plus 9. Okay, that's going to be 2x plus 10. So CA is 2x plus 10 times our 9. We're going to have to distribute on both sides. So 10 times x plus 13 and 9 times 2x plus 10. We get 10x plus 130 equals 18x plus 90. Now we're going to get our x's to the same side, so we're going to subtract 10x from both sides. We get 130 equals 8x plus 90. We're going to subtract 90 from both sides. We get 40 equals 8x. And then we're going to divide by 8 on both sides, and x is going to equal 5. Okay, one more problem. Okay, again, there's no letters, so I'm going to go ahead and add letters A, B, C, and D. Okay. Second, I'm going to decide, is it X, big V, little v, or weird V? So this is a weird V problem. We're going to again do the big V, little v side first. So from our vertex, it's BD is that segment, times the little v on that side, so BC on that side, equals the weird side squared, so BA squared. So now, for side BD, we have to add to get that whole side. So add 17 and x, so x plus 17 is that side. BC is just x, and then we have to do BA squared, so x plus 7 squared. Our next step is we have to simplify both sides, so we have to distribute. X times x is x squared. X times 17 is 17x. And now on the right hand side, x plus 7 squared, we have to think about it as x plus 7 times x plus 7. And we're going to FOIL. So first, x times x is x squared. Outers, x times 7 is 7x. I for inners, so 7 times x is 7x. And L for last, 7 times 7 is 49. We now need to clean up that right hand side and combine like terms. Our 7x and 7x are like terms, and that will get us 14x. So we now have the simplified equation of x squared plus 17x equals x squared plus 14x plus 49. Now the next thing I notice is that I have x squareds on both sides, and those are going to cancel each other out. So I'm left with the equation 17x equals 14x plus 49. I'm going to subtract 14x from both sides and get 3x equals 49. I'm going to divide by 3 and get x equals 49 thirds. You can go ahead and leave that as a fraction. Homework is special segments in circles with algebraic expression.